Welcome back to KFA Academy. Okay, 30 days NEET class course. So very important topics only we are going to discuss. I'm not going to cover the entire syllabus because it is not possible to cover the entire syllabus. So very important topics only I'm going to cover. In this class, I'm going to teach about mole concept. Even last year, one question was asked from this concept. So without wasting your time, we'll go to the topics. So 1 dozen, that means nothing but a 12. 1 pair, that is equal to 12. 2. So volume can be measured in liters. Like that. Amount of the substance can be measured in terms of. So mole is nothing but that is one of the basic SI unit. Amount of the substance. The unit is mole. First we will discuss the relationship between mole and the number. Okay, so 1 dozen, that is equal to 12. Like that, 1 mole, how can be measured in terms of 1 mole is nothing but 6.022 into 10 power 23. Okay, it may be atoms or molecule or ions. It is also known as Avogadro number. Okay, for example, 1 mole of any compound or any molecule that contains 6.022 into 10 power 23. 1 mole, that is equal to 6.02. Can you guess what about 0.5 mole? Yes, exactly correct. Half of that one. That means 3.011 into 10 power 23. So 0.5 mole is 3.001. Then can you guess what about 2 moles? Okay. So 1 mole is equal to 1 Avogadro number. That means in future can be written as 1 mole, that is equal to 1 Na. Then what about a 2 mole? So nothing but a simple mass calculation. 2 into Na. So what about a 3 mole? So 3 into Na. So what is the relationship between mole and a number? That is nothing but 1 mole, that is equal to 1 Avogadro number. So next we will discuss what is the relationship between mole and volume. Okay. So mole volume relationship. One mole of any compound, okay, any gas that occupies 22.4 liter. The liter can be measured in terms of decimeter cube or milliliter or cubic centimeter at STP and NTP. This STP, NTP is not that much difference. They are differ only in the temperature. Okay, NTP means 20 degrees Celsius. STP means 0 degrees Celsius. That is the only difference between STP and NTP. But there is no change in that pressure. Pressure is for both cases same value. So 1 mole of H2 gas. So it occupies 22.4 liter or 22.4 decimeter cube or 22,400 ml. In case 3 moles of N2 gas. So 3 into 22.4, 67.2 liter. That's it. That is a relationship between mole and volume. So now we have all, okay, number of volume and mass. So if particles are given, it should be divided by Avogadro number. Okay. If mass is given, divided by atomic weight or molecular weight. If volume is given, divided by 22.4 liter. That's it. Very simple formula. Number of moles, number of particles divided by Avogadro number, given mass by atomic weight or molecular weight, or given volume by 22.4 liter. Okay, so by using this formula, we can find. So 1 mole is equal to atomic weight, 1 mole is equal to Avogadro number, 1 mole is equal to 22.4 liter. Okay, so we will discuss some PYQs based on this concept. Okay, so recall this one, number of atoms, number of molecules. So mostly questions based on this two only. Maximum number of atoms or calculate number of molecules. Okay, number of atoms formula. Take a screenshot of this one. Number of moles into Avogadro number into atomicity. Number of molecules, same thing. Number of moles into Avogadro number into molecularity. Number of atoms or molecules is directly proportional to number of moles. Take a screenshot. Okay, we will discuss some problems. So number of atoms present in 17 gram of ammonia approximately. There are 4 options are given. So what is given here? First of all, mass is given. Okay, so how can you find a mole? So simple thing. Okay, number of atoms, that is equal to weight by molecular weight. So how can you find N? So N that is equal to, that means number of moles. Given mass 17 gram, molar mass of ammonia 17 gram. Okay, into, because they are asking atomicity, atoms. One molecule of ammonia have 4 atoms. So 4 into Avogadro number. So 17 will get cancelled. Okay. So 4 into Avogadro number. 4 into Avogadro number is nothing but approximately 24 into 10 power 23. So the option is D. Okay. So next question. Okay. So this question was asked in 2024. Weight is given. They are asking number of. Simple concept. So how can you find? So NO that is equal to given weight, given mass 12 gram. Atomic mass of carbon that is equal to 12. So number of atoms that is equal to N. So 1 Avogadro number. So answer is 6.022 into 10 power 23. Which one of the following has maximum number of atoms? Okay, how can you find? So very easy thing. For everything you can find a number of moles. So N that is equal to 1 by given mass, atomic mass is 24. First atom. Second one, that means B options. That is equal to 1 by oxygen molecule 32. Then third one, 1 by 7, and N4, 1 by 108. So very simple, given mass by atomic mass or molar mass. So in all the cases, denominator is same. Okay, so only we have to check, all the cases, numerators are same, only denominator we have to see. Okay, so denominator, we know, okay, denominator increases, value will decrease. So 108, it is the lowest value. Okay, then 32, 24. So the lowest denominator is 7. So the option is 3. 1 gram of lithium that contains maximum number of atoms. In all the cases, the amount of the substance is 1 gram. So in which case the number of molecules of water is maximum? NEET 2028 question. Okay, NEET 2028 question. So convert into mole. That will be very easy. So 18 ml. Okay, 18 ml. So we know very well 22.4 liter, that means 22.4 ml that contains 1 Avogadro number. Okay, then what about the 18 ml? That we have to calculate. So 1 by 22 4000 into 18. Second, this is a A1. Okay, then B is 18 0.8 gram. 0.8 gram. So mass is given. Molar mass of water is 18. So 18 divided by 18 0.01. Okay, then C option. Here the 18 ml. Listen here. So 18 ml. So given mass by molar mass 18 by 18, 1 Avogadro number, 0.8 gram, 0.8 divided by 18, that is equal to 10 power minus 2 into Na. Next case, 0.0224. So we know very well 22.4 liter contains 1. Then what about 0.0224? So the answer is 1 into 10 power minus 4. The last one is 10 power minus 3 mole. 1 mole contains 1 Avogadro number. What about 10 power minus 3 mole into 10 power minus 3? So if you are calculating all those things, okay, so option 1 contains maximum number of water molecules. So next question is, okay, see, All India Pre-Medical Test 2015, this question was asked. If Avogadro number changed from 6.022 into 10 power 23 to 10 power 20, then what will happen? Actually, this Avogadro number is defined based on the carbon 12. So 12 gram of carbon 12, that is equal to 1 mole of the substance, that is equal to 1 Avogadro number. In case Avogadro number change, surely what will happen? The mass of 1 mole of carbon atom will change. C and D is irrelevant to the options, irrelevant to the questions. Okay, the definition of mass in unit of grams and the mass of 1 mole of carbon. So C and D we can neglect. Okay, A and B, that the mole is defined based on the carbon 12. So the answer is B options. So here we calculated, okay, 6.022 into 10 power 23, that is equal to 12 gram. Then what about 6.022 into 10 power 20? So mass of the carbon will be reduced. All India Pre-Medical Test 2010, this question was asked. Number of atoms in 0.1 mole of triatomic gas. So very simple, it is not that much difficult. Sorry. 1 mole that is equal to 1 Avogadro number, that means 6.022 into 10 power, 1 mole that is equal to 6.022 into 10 power 23. Okay, since it's a triatomic molecule, we got to multiply by 3. 1 mole that is this much, then what about a 0.1 mole? Very simple. into 10 power minus 1. So 6.022 into 10 power 22 into 3. Okay, 23 become 22 because we are multiplying by 1. So 6 into 0.22 into 10 power 23 into 3. So if you are multiplying approximately, okay, so 1.8. Okay, 1.8 into 10 power 20. This is the answer. So 1.8 into 10 power 23. So next question, volume occupied by one molecule of water. So one of the important concept, just a little bit confusing. Okay, All India Pre-Medical Test 2008. Volume occupied by one molecule of water, they given density. Okay, A 9.0, B 6.0, C 3.0, D 5.5. In all the cases into 10 power minus 23. 1 mole, that means 18 gram. So 18 gram means 6.022 into 10 power 23 mole. So 6.022 into 10 power 23 molecules, the weight is 18 gram. If I want to calculate one molecule, so 18 divided by 6.02. So density is given. So we know the relationship. Okay, so nothing but a relationship is nothing but a density, that is equal to mass by volume. Okay, so already I have a volume. So already have a mass. So volume, that is equal to mass by density. So mass we are calculating. How we are calculating? 18 divided by Avogadro number. The density, that is equal to 1. So approximately if you are dividing, that answer is 3 into 10 power minus 23 centimeter cube. So one molecule of water occupies 3.0 into 10 power minus 23 centimeter cube. The number of atoms in 4.25 gram of ammonia is approximate. So how to calculate? So simple things. So mass is given 4.25 gram. Okay. The molar mass of ammonia is 70. If you are cancelling, approximately we will get 0.25 moles. So we know very well what is 1 mole. 1 mole, that is equal to Avogadro number 6.022 into 10 power 23. How many atoms are there in one molecule? 4 atoms are there. So in 1 mole contains into 4. So I have 0.25 mole. That means 4 into 0.25 to 6.022 into 10 power 23. That will become 1. So approximately 6.022 into 10 power 23. So once again I am telling you this here. Mass is given. Given mass by molar mass, we can calculate more. Okay, one molecule contains 4 atoms. So we know how many molecules are there in 1 mole. So 6 Avogadro number into 4. So already we calculated number of moles. So number of moles into atom. 4 into 6, 0.25 into Avogadro number. Okay, the next question. The total number of valence electron. What do you mean by valence electron? Yes, very good. Valence electron is nothing but the electrons present in outermost energy cell. Okay, so we know the electronic configuration of nitrogen. What is the electronic configuration of nitrogen? So nitrogen atomic number 7, 1s2, 2s2 and 2p3. So the valence electron of nitrogen is 5. For one nitrogen, 5 electrons. So there are 3 nitrogen. So 3 into 5, okay, total 15 electrons are there. Since it is N3 minus, 16 electrons are there. So N3 minus is nothing but azide. Okay, now we have to calculate total number of electrons of 4.2 gram. So convert into mole. How will you convert 4.2 into atomic mass of nitrogen? 14. 14 into 2, 42. So it will become 0.1. 0.1 mole. Now you have. Convert into molecule. How will you convert? 0.1 into Avogadro number. 6.022 into 10 power 23. Okay, one molecule contains 16 electrons. What about this many electrons? This is the question. So I hope you understand. So first we are calculating the valence electron of azide, that is 16. Then we converted the given mass into mole and mole into molecules. So multiplied by Avogadro number. One molecule contains 16 electrons. So one molecule, how we are going to calculate? Nothing simple. So Avogadro number, take it as Avogadro number. So 16 into 0.1. So 1.6 into Avogadro number. 1.6 into Avogadro number. Okay, the next question. 2025 question. Last year this question was asked. Okay. Among the following, choose the ones with equal number of atoms. So we have to calculate equal number of atoms. Mass is given. So convert the given mass into mole. Okay, mole into molecules. molecule into atoms. Simple concept. Okay. So how are we going to solve? So number of atoms. We know the formula. Atomicity into moles into Avogadro number. Number of atoms of sodium carbonate. So given 6. Okay. There are 6 atoms are there into given mass 212 into Avogadro number and molar mass of Na2CO3 106. So total number of atoms 12 into Avogadro number. The number of atoms of Na2O. Okay, Na2O, how can you calculate? So total number of atoms 3. Okay, given mass is 248 divided by molar mass, so molecular mass 62, that is equal to 12 Na. And number of atoms of NaOH. Total number of atoms of NaOH in one molecule. 1 Na, 1 O, 1 H. That is equal to 3. Okay, given mass is 240 into Avogadro number divided by 40. Answer is 18 Na. Number of atoms in H2. So there are 2 atoms in one molecule. Given mass is 12 and Avogadro number divided by 2, 12 Na. As like as number of atoms in one molecule of carbon dioxide 3. Okay, given mass is 220 divided by molar mass of CO2 is 44, 15 Na. By seeing that, okay, A, B and C, all 3 have same number of molecules, so same number of atoms. So already we solved A, B and they have same number of atoms. So A, B and D is same number of atoms. I hope you understand the whole concept. Okay, for you, one question. So the number of moles of oxygen in 1 liter of air containing 21% of oxygen under standard conditions. This question was asked in All India Pre-Medical Test 1990. Comment your answer. For more, follow our channel. Thank you. So the 30 days NEET class course, we are going to discuss all most important concept. Stay in touch. Thank you.